Okay, so first of all, welcome to the last session for training for kangaroo competition. I'm going to remind you first about how to register for the competition. Okay, so first of all, go to www.kangarooksa.com and then you're going to press on the registration. And then you're going to put your ID number or the email address that is assigned for Mawhiba, and of course, the password, and follow a few steps so you can sign up for the competition. Please don't be late on 22 February, the deadline for registering for Kangaroo. Do it before that time, okay? Now, we are going back to the questions. And as I told you before, we have 30 questions. The first 10 are the easy questions, 3 points each. The next 10 questions are the medium questions, and the third are the hard 10 questions, hard problems of 5 points each problem. Okay, and of course, during the competition, you're not going to have them all arranged in the order. Each one will be randomly picked. So maybe you're going to do first question, the hard problem. My advice is skip them and focus on the 3 points question because you can solve them fast, and then you can move on to 4 points and lastly 5 points. Okay, now we solved that problem. 26. We found the prime factorization of each number, and of course we took the common numbers. We directly thought about the prime factorization because those circles are going to be multiplied. So in prime factorization, we have multiplication. That's why we thought about prime factorization. And we need common numbers between those 4 numbers. So directly prime factorization is our way how to solve it. And we use this condition. Don't forget about it to know that I have 3, 4, 5, 6, 7. Maybe at the end you're going to use it. Maybe at the beginning. It's according to from where you started. Now we're going to solve number 27. So I'm going to pick randomly. So, okay. Mustafa, can you start?
Yes, Mr.
Okay, Mustafa, number 27.
Which of the following nets cannot be folded into a solid?
Okay, we have the shape and we have those choices. Of course, you don't have enough time to draw them and fold it and see
Yes.
which one. So you're going to imagine.
Mm, I think it's not going to be C because I think we can look so we can see the minuses so on like the corner. So we're gonna fold them to up, and on the other side we're gonna fold them up.
Okay,
Uh,
remember, this one will be on the top and this one will be on the side. And those are going to be here. So this plus will stand for this union. And this one will be here. This one will be on the top.
so the minuses on the other place will be on the top, and then we close them from the sides, and then we close them from the other side. So it's
Okay, but
not gonna be C.
but remember, I will tell you a small hint. We can turn the shape. So after folding it, the one on the side will be vertical lines, two vertical lines. And the one on the top will be horizontal lines. So if we turned our shape, we're going to obtain up vertical lines and down we're going to obtain vertical lines.
No, Mr. I think it's gonna look exactly like the picture.
The C can be exactly like the picture, right?
Yeah, I think it's
Yes,
is.
so I prefer to
not
cross
it.
it out.
Yeah,
And
I'm telling you to cross it out
yes, so let's try each one
because I
alone.
want to start, Mister, with the obvious ones, Mister.
Yes. So do you have anything obvious here you can imagine directly?
I think we can. I think we can cross off A. I think maybe let's try.
Let's
A is
see.
gonna go over
So
here.
if
So
we fold
it's
that
minus
one,
fold up. It's gonna go up.
so this one on the top.
Mm.
Okay, so on the top I will see lines and I will see the plus on the side, and those are going to be vertical. So also if we flipped it the other side, the plus will be from this side, and those are going to be switched. Two verticals and two horizontal, the same as the picture, right?
Mm.
So let's cross it. Let's try the B.
B doesn't look very. It looks like it could be the answer, but I don't know.
Okay, so
So
you're going first to take those up,
these
right?
up, yeah, this one, and then the other ones on the sides, and then we're gonna fold them. How?
We're going to fold all of the shape to keep one up, and two will go on the top, and this one will go.
Mister, but I have a question. Is the one asking if we can put if it looks different from it, or it cannot
Yes,
be.
it
It
cannot
look
be. So it will be different.
it cannot be this shape.
Yes.
Yes. Of course. The I think maybe it's B
Maybe it's
because
B.
it's mm,
Okay,
or or E.
I will write M because maybe this. So let's try the D.
Mm. D is oh D is the go like
Those
we
two,
can
of
see the
course, they
minuses
are
here.
going up.
The minuses here are gonna go up, and the ones on the right are gonna go to the left.
Okay, so those, if they went up and then we folded it like this,
Yeah.
after raising it, to make those beside those, and this one will be folded up also, those two units, and those will meet those two on the top, but we will flip it later to make them at the bottom, of course. So let's imagine their shape. So those are going to be vertical, and I have the plus here. Even if I change the shape of it, it's not going to remain a choice for us, right?
Yeah.
But no, remember, those will be up. No, the same, the same. Without flipping it to the other side, it will be the same. No need to flip it. This one is clearly the same.
Is it the
So
same?
I'll
Because it
cross it
has the same
directly.
shapes. Has the
Yes,
same shapes.
Those two, we flip them back after joining them. We flip
B,
them in our imagination.
I know. B, maybe because it doesn't have the same shape.
Okay, maybe. E. If E is for sure the same, then directly we are going to take the B.
B.
So, how are we going to flip it? Those two minuses, of course, they are going up and those are going down. Those, okay, but remember, in this case, I'm going to have two sides opposing each other. So if this one was not my choice, I will take the other two sides. So always is going to be true. Always. So yes, you are sure you are right.
B. B.
Yes, thank you so much.
Welcome.
Okay, guys, so I know you are all confused in this question, but the problem is we cannot solve it using any rule, using mathematical rules that we all know. So we must imagine. And as you can see, me and Mustafa imagined the shapes, and we found that B is the only one that can never be in this shape. So you must put them in your head and start flipping them. I know it's hard, but those are the last questions, so always they are hard. Okay, we're going to move to number 28. This number, yes, is a mathematical number, so we can solve. I'm going to choose. Yes, Nawaf.
مستر مين نواف مدافر.
Yes, I need you to read for us, and
Your voice is lagging, mister. Mister,
yes, the question,
I read the question.
number 28. Yes, please.
Okay, because your voice was laggy. The
Oh,
four
I'm sorry.
villages A, B, C, and D lie along a road in that order. The distance between neighboring villages is 10 kilometers. There are 10 students who live in village A, 20 students who live in village B, 30 students who live in village C, and 40 students who live in village D. The villagers want to build a school so that the total distance traveled by the students when going to school is as small as possible. Where should they build the school?
Okay, so clear, you understood that we have four
So please,
villages
can
and
I
we need to
answer?
build a school. No, the waffle will answer this question. So my advice in mathematics, not only in Kangaroo, always draw your given so you can understand it. We are going to write A, B, C, and D.
Yes.
And remember, we have 10 kilometers between each village. So between A and B, there is 10. Between B and C, there is 10. And C and D, there is 10 kilometers. And how many students we have? I'm going to change my color. So 10 students in village A, 20 students in village B, 30 students in village C, and 40 students in village D. So the question was, we want to make a school, to build a school, and the total distance traveled by the students, it means we are going to find the average when going to school is as small as possible. So what ideas do you have?
I think I would put the school between B and C.
Between B and C? Are you
Yes.
sure?
Not
Remember,
sure.
if we put the school between B and C and in the middle between B and C, so it will be here.
Yes.
So we are going to calculate for each choice how much they are going to travel, okay?
Okay.
So can you start calculating?
Yes.
So let's start from A, the
Yes.
first choice. So if we build the school in A, how much are they going to travel?
It will be close. I don't think.
Yes, but we must find exactly the number. So 10 students in A will travel how much miles?
Zero.
Yes, of
Yes.
course. Then 20 students from B, how much are they going to travel?
10.
Okay, so each one will travel 10 kilometers. 20 times 10 is what?
20 times 10. 200.
Great. And then from C to A, how much? First of all, the distance.
20.
20. I have how much students?
30.
Okay, so 20 times 30 is
20 times 30. 600.
yes. And the last choice, D, from D to A.
It will be 40 kilometers.
40 kilometers, are you sure?
No, wait. 30.
Oh, yes. So 30 kilometers times the number of students.
30 times 40.
3 times 4.
3 times 4. Wait. 12. So
Okay, and two zeros.
1200.
Yes. So if we added those quantities, we are going to obtain 200 plus 600 is 800 plus 1200.
2000.
1000.
Yes. So 2000 total kilometers. Okay.
Yes.
Now go for the choice B and we are going to compare. So from A to B,
10 kilometer.
and how many students we had in A?
10.
Yes, so 10 times 10,
100.
great. And from B to B, 0
0.
kilometers, yes. From C to B,
It will be 100. No, 3.
300, right. From D to B,
It would be 20 times 40. 800.
okay. So the answer will be,
It would be 1200.
yes.
Yes.
So of course you can see between 2000 and 1200 there's a lot. So of course A, we can cross it out.
Yes.
Now the choice C, the one
Yes.
that you said it might be. In the middle between B and C, so from B to
It
the
would be
choice C will be,
5.
yes. So
Okay.
let's start from A to the school. How much kilometers? The distance is
15.
what? 15, right. And how many students?
10.
So
So it
15
would
times 10,
150.
how much?
No, wait.
I couldn't hear you, not wrong or something.
150
Yes. Now from B to the school, how much distance I have?
times 20, 100.
So 5 kilometers times 20 is 100, right? From C to the school,
From C to the school, wait. 150.
Okay, so 5 times 30 is 150, right? And from D to the school.
It will be 15 times 40.
15 times 4
Is 60.
add a 0.
It will be 600.
So the total will be
150, 153. It will be 1000.
great. So in this case, we crossed away A and B.
Yes.
So till now, C is our choice. Let's try D. Sorry, not the point D. I mean D the choice. So in C.
So it will, and we start from 5.
Yes. So if we build our school in C on the in village C.
10 times 20, 200.
Yes, 200 plus.
Plus 10 times 20, same thing, 200.
Okay. Now if we build in C, so of course 0.
Yes.
And from B to C.
40 times 10, 400.
Okay. So what is the total?
100, 800.
Okay. So it's smaller than all of them. It's the smallest one till now, right?
Yes.
So we crossed choice A, choice B, choice
B.
C. Now D is our answer till now. Let's
Yeah.
go for the last one. So if we build our school in D, A, how much are they going to travel?
Okay, they are going to travel, which is 300. 10 times 30, 300.
Okay, 300 kilometers. Plus from B,
20 times 20, 400.
great. From C,
30 times 100, 30 times 10, 300.
300. And of course, plus 0, it will be the total.
1000.
1000.
So the answer is D.
The answer is D, right? So we have no other choice. We must try them all, and then we will choose the right one. And of course, those were crossed. Not C, sorry.
Answer D.
C
Yes.
was crossed. The answer was D, and we crossed finally the A.
Teacher, we
After
crossed the E because it's like A. No difference.
E.
Both E and A are similar.
No, you mean E and C. So till now, any questions? Do anyone have a question?
No.
Okay, this question, I'm going to skip it now. Let's go directly to that one, and then we're going back. So, going to ask Hala.
Yes.
Yes, Hala, are you, please, I want you to read the question for us, and you're going to start thinking of how to solve.
30 people are sitting around a circular table. Some of them are wearing a hat. Those who do wear a hat always tell the truth, while those who do not wear a hat can either lie or tell the truth. Each person says at least one of my two neighbors is not wearing a hat. What is the largest number of people who could be wearing a hat?
Okay, so simply in math, draw. But of course, we're not going to draw all the 30, but we know that circle table and 30 people sitting. And I'm going to highlight what they said. different color. I'm going to highlight. Let's take the documentation. So, what ideas do you have?
I don't really understand the question.
Okay, so we know that there's a circular table. 30 people are sitting around this table, and there is some of them wearing a hat and the others are not wearing a hat. So each one wearing a hat, he is always true, but the one that is not wearing a hat can lie sometimes, and sometimes he's right. He's not saying the true, or he's saying the true. So all of the persons, the 30 persons, said the same sentence. At least one of my neighbors is not wearing a hat. He can be on the right, he can be on the left, he can be not existing. Maybe he's lying. There is no one sitting beside him wearing a hat. No one knows. Now, the question is, what is the largest number of people who could be wearing a hat?
I will guess maybe 15.
Okay, so directly you thought about 15 taking the middle of 30, dividing it by 2, right?
Yeah.
Okay, in fact, we cannot do this in this question. Remember, this is a 5 points question, so if the answer was so much clear, it will be a 3 points question, not 5 points. So, of course, not. Now,
So it's not 15.
maybe not. We must do the sample and try thinking about the question. So we're going to choose someone to answer. Now, anyone have an idea how to solve it? I'll give you 2 minutes to think about it because it's not so hard. At the same time, it's not so easy. So think about it. Of course, someone will answer. Walid, do you have any ideas?
Mister?
Yes, Walid, do you have any idea?
No, I am Nawaf. I have.
Oh, Nawaf, yes.
I also do.
Okay, we'll start with Nawaf.
I think it would be 15. It would be two hat, two no hat, two hat, two no hat.
Okay, let me try it. So if two are wearing a hat,
And then two no hat.
I would say and no hat. So and and of course before the H we have and no
And
hat. So
so it would
always
so it would
true.
be
Yes, so the H is always true. So one of my neighbors is not wearing a hat. Yes, we can see that. One of my neighbors, also this one is true. This one will be also true. This one is true. So all of them them are saying the truth. No one is lying here. So maybe the C. Maybe. We're not sure yet. But this one works. So what is the largest number? So directly we can take away the 10 and the 5.
Yes.
So maybe C, maybe D, maybe E. We must test more to find if it's true. So let's see Walid what he have ideas.
First of all, we focus on what they say.
Okay. Which one?
It says at least one of my two neighbors is not wearing a hat. It
Okay.
never said it's not like it's guaranteed. At least one of my two neighbors is not wearing a hat. There is a chance that, first of all, they could be lying, which could be a high chance.
Okay, but remember, if someone is saying the truth, at least one of my neighbor is not wearing a hat, it means maybe two or maybe one. At least so.
Can I continue?
Never there is no one sitting beside me not wearing a hat. If I'm not lying, if I'm saying the truth.
Well, for me, what I think that it is, well, at least there gotta be some. It's not guaranteed, but some. That in the area, this guy is.
Yes, of course. It's guaranteed that there is someone sitting without a hat. If I'm
The
saying
guy
the
is
truth.
lying. Wait,
But remember, the people with no hat, sometimes they say the truth, sometimes they are lying on us. So you cannot be 100% sure because of those not wearing a hat.
can I continue?
Yes.
Basically, in the middle of those two is two people wearing a hat, or he isn't wearing.
How?
Basically, he isn't wearing while the person on his right and on his left could be.
Okay, so I got your point. So you will start by saying the one, anyone is wearing a hat. He have two neighbors. So they can be, what choices do I have? Remember, wearing a hat, he is always saying the truth. So at least one of my neighbors is not wearing a hat. So maybe one of them is with no hat, or maybe two are with no hat.
For me, I think it can be 20 or 25.
Okay, but we will not guess. By guessing, of course, we can terminate the A and B directly. But maybe C, maybe D, maybe E. So we are not going to choose between them because you know the percent of choosing among three choices is 33.34%. So we don't want to go through this. We need to be a little bit sure.
Basically, let's say, I think for me 20. Because if what I say is true on every single one, which is 2 out of 3, and the 3 becomes 30, and then the 2 becomes 20 for the other 10.
Okay, let's represent what you said here because some of others don't know how to solve it. So let's represent them. I will change colors also. So if someone is wearing a hat, he is 100% true about this, right, Walid?
Yeah.
So one of his neighbors is not wearing a hat. One of them, at least. So maybe one, maybe two. but I need to find the largest number.
I'm gonna type what I need.
Largest number of people wearing a hat. So I'm going to stick on the idea of one of them only. I don't want the both with the no hat. So I will say this one no hat, and this one is wearing.
Here, this is how I mean. I mean, and no hat and then a hat and then a hat. Yeah, like this. This is what I mean.
Yes, but we cannot directly multiply it because we don't know yet those and those. So we need to test at least those and those to understand more. So by changing, first of all, I need to change the color. Okay, so one here is wearing a hat. The next one must be what?
I'm not wearing.
Not wearing, because he said at least one of my neighbors is not wearing a hat, so he must have a neighbor with no hat. And I'm going to test here. So this one can be wearing a hat or not wearing a hat.
Yeah.
Remember that this person said at least of my neighbors is at least one of them is not wearing a hat.
Gonna say he's gonna be wearing.
Yes. So this guy is lying on us, right?
Yeah.
And we have a choice that he can be lying. So simply I'm going to say with that. Now this one,
Uh, we can put it with a hat because his neighbor already doesn't have.
yes, because his neighbor already took this choice. So this one will be with hat, and this one will also be without hat because
Yeah,
he
without.
needs one. Yes. And here, no hat.
They with a hat.
Yes, because this person also is lying. So what you are saying here, we are going to build this pattern by saying that all of the people who's not wearing a hat are lying, and people who are wearing a hat are not lying. And the pattern is N, H, H, N, H, H, and so on. So yes, 2 out of 3. And to make the 330, 2 will be multiplied by 10. So 20 people are wearing a hat, and 10 people are not wearing a hat. Right, Walid? Thank you. So any questions?
Yes, it's just complicated.
Who was talking?
Ali.
Who?
Ali.
Ali. Okay. Ali, look with us. We're going to repeat the idea what happened. First of all, before why we chose this on this, I'm going to tell you a fact. In mathematics, everything we must represent by a figure to understand it more. So that's why I draw a circle, and those crosses are for people, and I wrote the 30 to understand that there's 30 persons sitting around the table. Now, if we went, if you want to know all the number, what should they do or something, we are going to study a small sample. By having a circular shape, I prefer taking 3 persons first of all as a sample. So they want the largest number of people wearing a hat. It means I'm going to start with age in the middle, and this age I'm going to apply the condition and see what can I do. So at least one of my 2 neighbors is not wearing a hat. It means one of my neighbors is not wearing a hat, or 2 neighbors are not wearing a hat. We chose to take the first sentence, the first meaning, because they need the largest number. So of course, I'm not going to put no hat, no hat. So I'm going to get C. No, I need the largest number. So I said maybe the one sitting beside him is wearing a hat, and one is not wearing a hat. So I got H, H, N. And so we moved. We tried a few on the right and on the left to make sure that our sequence is right. So this one is not wearing a hat. He said at least one of my two neighbors is not wearing a hat. So must add here without a hat. A person without a hat. But remember, he can be lying. He can lie or tell the truth. So maybe he's lying now. I'm not going to believe him. He's a liar. So take him. He's not wearing a hat because I need the largest number. The one sitting here is wearing a hat. So he is always saying the truth. So at least one of my two neighbors is not wearing a hat. Yes, I know there is one here is not wearing a hat. So I'm going to say this one is wearing a hat. And if we went to this side, this person is saying the truth. One of his neighbors is not wearing a hat. So this one is wearing a hat. The one here is not wearing a hat. Must be not wearing a hat. So this one will be, so this one will say the truth. And of course, after that, this one can also be a liar, and this one will be wearing a hat. So our pattern that we created can move on. So HHN, HHN, HHN. So two people out of three are wearing a hat. Or as a fraction, I'm going to write it 2 out of 3. To make the 3 to generalize it over 30, we must multiply by 10. And in mathematics, you know, if we multiplied the denominator, we must multiply also the numerator to get equivalent fractions. So 20 out of 30 are wearing a hat. And it's clearly our choice. Got it, Ali?
Yes, got it. Thank you.
Welcome. So, anyone have a question? Okay, so now we are going to move to the hard question. I'm saying hard because we must imagine a lot in this question, not like that the box that we folded. No, we need more imagination here. So I'm going to choose Abdulaziz.
Yes.
Yes, I want you please to read for us and to try thinking about this problem.
The three pictures show a structure made from cubes as seen from the top, from the front, and from the right. What is the maximum number of cubes that could have been used to build the structure?
Okay, so what ideas do you have?
I didn't understand the question.
Look, I will draw some figure for you. So if you have cubes and you put them near each other, above each other, and of course in the back of it, you're going to have a structure, right?
Yeah.
So that structure is not like a cubic structure. So it consists of cubes, small cubes, but it's not a cubic structure. It will be, if I looked from the top, so I'll draw for you an eye. If I looked from here, I will see this shape. If I looked from my place, how we are now seeing it on the screen, we will see this shape in front. And if we looked on this side from the right, we are going to see this shape. By the way, if we looked on the right or from the left, we are going to see the same shape. Now, the question is, what is the maximum number of cubes that could have been used to build the structure? You must count. I want to see how you're going to think about it because honestly, for me, it's hard. It took me like 5, 6 minutes to think about it. I want to see each one how he's going to think. Anyone have an idea?
Yes, teacher, but I don't think it will be good.
Okay, what is your idea?
Basically, you see all the things we have in front. First, let's see how much is the total, and who has the most.
Do you
Let's
know
start
that
from.
this is the way how to solve it?
Huh?
This is
Wallah.
the only way how to solve it, yes. So in total, let's
One,
start from the front. We have
1, 2, 3, 4, 5, 6, 7, 8.
look, don't think about the number of cubes I can see because remember, for example, this cube can be not in the first layer, maybe in the last layer, but I can see it like this because I'm not looking like I'm beside it. I'm looking from a far distance or I can see an image only, not the dimensions, how much is it far. Okay, so the idea that I started by saying from the front, I can see that there is a width of 4 and a height of 3 cubes, right? From
Yeah.
the top,
From here, from the top, we have the width of 3.
see,
The width.
1, 2, 3, and there's here also.
Yeah, but here it's only on the upper part, and the upper part has 3 also.
Yes, but we cannot see, we cannot read it like this.
So 4.
So 4 times 4, if we want to imagine the whole cube, and then we are going to start taking away cubes from it to have those 3 conditions. So the whole cubes, if we want to draw a whole cube, we are going to have 4
Here's 4.
times 4. And on the right, if I looked from the right, remember the right must be like the front because I'm talking about the high. The high
height
is always the same here, of course. So now the high is 3 and down it's
is 4.
4. So 4 times 3.
12.
So first of all, the volume, you all know it. We are not dealing with the cubic square here. We are dealing with the rectangular shape. So the volume will be side times side times side. It's like the cubic because when we took the powers, we talked about the volume of the cube. We said the any side power 3. So we are going simply to multiply 4 times 4 times 3. And if you don't want to think like this, you don't know the rule, so directly go to the idea by counting. So if I took it, for example, from the front, the same shape is going to be repeated how many times?
The same thing is going to be repeated 3 times.
No, 4 times. Imagine this one is moving 1, 2, 3, 4 times to get 4 on the top and on the right. I'm showing you the 4 that I want the answer of it. So 3 times 4 is how much?
3 times is 12.
Okay, so this is the area of the rectangle in the front, if it's complete. 12, how many times it's going to move inside?
Yeah, it's gonna move 4 times.
So 12 times 4,
48.
okay. So I will write the 48. 48 stands for, I don't have a missing part, I have a full shape, 48 cubes. And we are going to start taking off some of them. So let's start with the top, for example.
Yeah.
On the top, or we can start from anywhere, doesn't matter. So on the top, how many squares are missing to obtain a full rectangle or a square?
5.
So
No,
one,
more. 2, 3, 4, 5, 6, 7.
yes, 1, 2, 3, 4, 5, 6, and 7. So I have 7 missing cubes. How much is the height of this shape?
This 4.
No, the height. So I'm looking from the top. It will be repeated down how many times? The same of the height.
It will be repeated
Yes.
4 times.
No, 3 times because this one is from the top. How many times it's going to be repeated? The same number of the height. It's not going to be repeated inside. It's going to be repeated down. Okay, so we are going to multiply each missing one by 3. In other words, we can directly say that 7 times 3 is equal to 21. So from the top, I can see that there is how many cubes missing?
1, 2.
No, I can see that I have 7 cubes missing, and each one is missing 3 times in the height. So I have missing 21 cubes, right?
Yeah.
So simply I'm going to subtract it, 48 minus 21,
Equal 27.
27, right? So till now, 27 is my answer. But remember, we have front view and we have the right view. So if I went to the front view, I'll change the color here. So in the front view, this shape is on the top, and this shape is from the front. So I can combine them. But remember, I have 4, which is 4, which is right. 4 and 4. The height doesn't matter till now. Uh, I'm going to think that this square, for example, is going to be forward, the most one near us, right?
Yeah.
It will be here, and the rest will be in the back of it. But remember, we are seeing here a picture. We are not seeing the dimensions. So we are going back to the shape of the top. I have this cube to be here, and this cube will be where?
This cube to be to the place that is missing, which is
No, no, it can't be on the place missing because I can see it. So this cube will be this one, but here I saw it from up. From front, I'm going to see it here. So if we want to continue, we're going to say that I have from the front, I have missing how many units going inside?
Minus 1, 2, 3, 4.
Okay, so I'm going inside 4 and I have 1, 2, 3, 4 cubes missing. 4 times 4 is 16. So 16, 27 minus 16 is 21. And if we did the same here, we are going to get less than 18 even. Remember, there is a missing cubes here that they are already missed from here, from this figure. Okay? So what ideas do you have?
Now it needs imagination.
Yes, it needs imagination. So what I found that this cube have, for example, two cubes above it that are going to be missed, right? To obtain this shape. We can ignore this fact. We can see it here on the right. Maybe it's more clear on the right view. Let's go back to the front view. So I have here 4 cubes missing. But if I looked from up, they are already missing. And this one is down. So there is no 2 squares above it. And this shape also, everything is missing. I have this thing that I can see, and we have no cubes above it. Why we don't have? Because those two are empty and those two are empty. If they weren't empty, then of course we're going to have confounded cubes, but they are empty. So that's why I'm going to minus 4 out of my loss. It will be 27 minus 4, 23. So from this only we can derive 4. Why? Because we already took a lot out from here. We took 21 cubes. So of course we're not going to lose a lot. We lost them all. Now, in the right view,
It
so
has
let's start also imagining the shape. First of all, I told you this square is here, is in the front. So it's more near us. So this square is the same of this square. How many cubes are going to be above it and we missed them?
it's gonna be above it. 2.
Yeah, yes, so we missed 2 cubes till now. Great. So we are saying that our answer will be maybe 21, maybe less. So I can directly take away the E. Now, let's move on. So this one is this. Those two, I'm going to miss a cube here.
We got to imagine if I think we will miss it. Let me tell you why.
We will take how much?
We're gonna take one. Let me tell you why. I think
Why?
if we see here on the front one, the cube that was missing 2 from the right next to it to the right, which will become is 2 missing, which means we haven't fulfilled.
This?
Yeah.
Yes. So 2 and 2. Do we have something else missing that is missing here and we didn't minus it from before?
That is no.
Okay. So, but remember, wait. You said something wrong because this one we already missed it here. Missed it. here. It's not existing here. The missing cubes are not existing even, okay? So here there's nothing to minus. And also here we already minus them because we said those two will be in the front. So I'm going to miss 2 cubes from above. So no, in fact, I cannot miss anything else. So I can only miss 2 cubes. So if I took away 2 cubes, my answer will be 21.
21.
So in our imagination, I know you have a headache now, but always 3 dimensions, you must do those imaginations to solve them. That's why they cause a headache. So using our imagination, we don't have missing cube anymore. So directly we can go. Okay, now I'm having an error in my imagination because Walid is right. Yes, Walid, you are right.
Okay.
Yes, this one will make me lose more 2 cubes. You are right. I imagined that wrong.
With imagination.
So I missed 2 cubes from here, 2 cubes from here. So I will lose 4 cubes, right, Walid? That's why I believe in you. So 23 minus 4 will be what?
19.
How much?
19.
19. So what is the answer?
The answer will be B.
Yes.
It's a simple question, but the only hard part about it is that the imagination, because you can
Yes,
get
it needs imagination. You cannot, we don't have enough time to bring cubes and just build them up and we'll see. Of course, we don't have time for that. That's why. By the way, I'm pretty sure that this kind of questions no one will answer or will answer randomly. But I'm pretty sure that Walid will do it in the exam. He will answer this question. Thank you all. I know there's a lot who didn't get the idea. We used our mind, so our imagination said that we missed this kind number, this number, this number. The only trick here is directly to calculate how many cubes I have if the shape was complete, not without missing points. And then we started taking away the missing cubes. Okay, so we must imagine. Thank you all and good luck for your exam.
Bye, teacher.
Bye
Bye,
bye.
teacher.
Bye.
Bye.
teacher.
Bye
Bye.
bye.
Bye, mister. Bye.
But teacher, when is the exam?
In March, after in semester 3, trimester 3, don't worry.